Hello everyone, in this video we will be learning about arrays. So what is an array? An array by definition is a collection of items stored in contiguous memory locations, and those items are homogeneous in nature. So what does that mean? So items being homogeneous means that all the items belong to the same data type. So I can store 10, I can store 4, 5, 6, 7, n number of variables of the same data type together. And what does contiguous mean? So basically what the compiler will do is when I'm trying to define an array, it'll go into the memory location. And since I've defined it as 10 over here, it'll try to find a space in which I can store 10 integers continuously one after the other without any gap in the addresses. So let's say if I'm actually defining it to be a size of 7, what let's assume this is how it is in the memory, wherein it is able to find 1, 2, 3, 4 and so on 7 places wherein now I can store integer data continuously. So this is basically what an array is. And now let's see some terminologies which are associated with array. One of the things you can see here is I've tried to number each of these boxes, and I've actually begun the numbering from 0 and not 1. This is because these numbers associated to each box are called indexes, and indexes always begin with 0. So to access the first element of the array, I will have to use the index 0. To access the second element, I'll use the index 1. To use the third element, I'll use the index 2. So on. So now let's see how we can declare or define and initialize an array. So there are three ways of declaring an array without using pointers though. So first one is simple, wherein we use the int keyword, the name of the array, square brackets determine that this variable is going to be an array variable, and any number written within these square brackets is the size of the array. What this will do is it will go to the memory, it will find 7 such memory locations wherein I can store integers, and then it will take those memory locations, take its first address and give it to ARR1. Basically ARR1 is used to represent the entire array. One thing to note is that the values present in each of these boxes in this case will be random. So you'll have garbage values present in each of these boxes when you actually try to create an array like this. The other way of initializing and declaring and initializing an array would be we use the same thing, keyword, name of the array, square brackets, size of the array, and then we actually provide some number of elements to the array. So in this case, anything written within parentheses will become the first first how many ever elements of that array. So in this case, if my array is ARR2, what will happen is in the 0th index I'll have 1, in the first index I'll have 2, in the second index I'll have 3. And one advantage of doing it in this way is that the rest of the spaces which are not yet filled will automatically be initialized with 0, etc. Now the third way in which we can declare and initialize an array would be again int keyword, array name, square brackets. This time we don't actually specify the size of the array. Instead, the list which we provide for initializing, as many number of elements are there in the list, that will become the size of our array. So in this case, array ARR3 will be of size 4. So now let's see how we can actually access the elements of an array. So accessing the elements of an array is also quite simple. What we do is we use the array name ARR1, we use the square brackets, and within the square brackets we write down the index which we want to access. So the element of which index we want to access. So for example, if I want the third element, which would be index number 2. So if I do ARR1, 2, then let's see what we are observing. We see that it's gibberish. So if I try running it again, I'll get different values. It's because each time the array is being created. It's initialized with garbage values, and hence I'm able to do this. Now let's actually try to access some value which we know will exist correctly. Okay. So what do we see in ARR2? I'm accessing the second index, which would be the third element. So 0, 1, 2, which is actually the integer 3. So this was about arrays, how we initialize and how we declare and initialize them, and how we can access its elements. So one more thing which we may want to know is, for example, let's say I have an array like this, in which there are quite a few number of elements, and I actually don't want to spend time trying to calculate what is the size of the array. So one of the ways which we can actually try and find out the size of the array is using the size of operator. So as said before, the size of operator will return the size taken by a given variable in bytes. Since ARR1 is the name of the array in this case, its space occupied will be equal to the space occupied by the entire array, which will be all the boxes in each of these indexes combined. So what we can do is, after we have that entire big size, what we can do is we can just simply divide it by the size taken by one of the boxes in that array, which will essentially give us the size of the array. So how that works is, okay, comma, n. Oh, okay, right. Finally. So here we can see that the size is 7. So let's also try and print out each of the sizes individually. So size of ARR1, out size of ARR1, and the first element. This is 0th index. We see that the size of ARR1 is actually 28, and the size occupied by one of the boxes, one of the indexes, is 4. So the total size of the array is 7. So now let's just briefly discuss some advantages and disadvantages of arrays. So since we can directly access each element using, if we know the index, it makes accessing of random elements very quick. So we can quickly go from knowing what the 0th element is to the 4th element to the 6th element and so on. Similarly, it uses fewer lines of code to actually create a single array with multiple elements. It's easy to access all the elements. Traversal of the array also becomes easy because we can simply iterate over a single loop. So let's see how we can actually iterate over an array. So for int I is equal to 0, so I have an index. What I'm going to do is I'm going to travel all over the size of the array. Course of habit, sorry. idx I plus plus, and we see out ARR of idx. This is how you would ideally iterate over an array, which is quite simple. And and one of the other advantages of an array is that sorting of an array becomes easier because we can write it in fewer lines of code. Now the disadvantages of an array would include that we may not always have in memory enough space to give for such contiguous allocation. So what if I want an array of 10,000 size or 1,000 size? It may so happen that we do not actually have that much time. I mean, we do not have that much space available in our memory. Or rather, we don't have that much space available contiguously in our memory. And other thing is, once we fix the size of the array is fixed. We cannot change it. We cannot change it without actually having to use more costly ways in which we either decrease or increase the size of the array in which we look at other memory locations in which there is actually a contiguous memory present, which is required, like which is equal to the required size, and then we again copy, or we initialize the array over there, then we copy all these elements to that array, etc. So insertion and deletion of elements in the array will become difficult. And yes, this was all about arrays. Thank you.